Hello and welcome, everyone. My name is Adam Tyndall-Schlicht, and I'm Director of Port Milwaukee. Thank you for joining us for this virtual walking tour of the envisioned Dredged Material Management Facility, or DMMF. This recording today is meant to simulate a walking tour that is currently scheduled for the evening of January 13th, 2022. And we wanted to avail this recording to ensure that everyone that wanted to join us or couldn't due to inclement weather or for any other personal professional reason had access to the information that is shared and will be shared with all DMMF or area of concern or waterway restoration partnership interested community members. Today, joining me are various subject matter experts from an array of public organizations that are working hard to realize what we consider to be a generational opportunity to clean up and restore Milwaukee's harbor and Milwaukee's waterways, including its three rivers. The walking tour itself will include a series of stations in which live attendees will be able to actually see those locations that will be impacted by this generational project. And again, this virtual walking tour today, as recorded, will be going over the same content as available to you on a 24/7, 365-day basis. A couple key introductions. Again, my name is Adam, Director of Port Milwaukee. And the Port is one member of the Waterway Restoration Partnership, an organization with whom we hope you become familiar. The Waterway Restoration Partnership is a team of public and nonprofit community organizations, including the Port, MMSD, the DNR, and other organizations that you'll hear from today that are pursuing the area of concern or AOC work. This is an effort to delist Milwaukee Harbor as an EPA designated area of concern, which it's been designated as such since the late 1980s. Milwaukee has a port, and the proposed Dredged Material Management Facility will be based near our facility on Jones Island. What is a Dredged Material Management Facility, or DMMF? The proposed structure will provide for the safe, secure, and permanent containment of approximately 1.9 million cubic yards of sediment that will be removed in the years ahead from the Milwaukee, Menominee, and Kinnickinnic rivers. In the map laid before you, you can see that the proposed structure is being built off of an existing structure already on Jones Island, which is operated by the Army Corps of Engineers. So sediments have long been safely stored on Lake Michigan here at the port, and the new structure will be an expansion of that existing work. As of today, again, this is being recorded on June 13th, 2022. We anticipate that construction of the new structure could begin as early as late 2023 or early 2024. It will take just over a year and change. Ideally, construction will be completed in 2025. And to discuss more about what that construction looks like and how the DMMF will be used, are various subject matter experts joining me today for this recording. It's a pleasure to introduce our next speaker, Brendan Dow. Again, welcome.
Thank you, Adam, and thank you to everyone for attending the Dredged Material Management Facility virtual tour. My name is Brendan Dow. I work for the Wisconsin Department of Natural Resources in the Office of Great Waters. I am the Milwaukee Estuary Area of Concern Coordinator, and in my role, I oversee and manage the AOC program for Milwaukee. I'll be covering an overview of the area of concern, and we'll actually be returning later in the virtual tour to talk about the sediment cleanup in more detail. Next slide, please. So first, what is an area of concern? An area of concern is an area on the Great Lakes that has a history of significant environmental degradation from human activities preventing people and the wildlife from fully using or enjoying the local waterways. The map that you see on your screen is a map of the 5 Great Lakes, Lake Superior, Michigan, Huron, Erie, and Ontario, with 31 highly degraded shoreline areas in the US and 12 on the Canada side of the lake that were identified as areas of concern in the 1980s by the Great Lakes Water Quality Agreement, which formally named Area of Concerns, or AOCs, 5 of which are binational AOCs shared between the US and Canada. Next slide. Wisconsin has 5 area of concerns: the St. Louis River in the Lake Superior Basin, and in the Lake Michigan Basin, the Lower Menominee River, Lower Green Bay and Fox River, Sheboygan River, and the Milwaukee Estuary, which is called specifically out on the map in red. All of the AOCs are at different stages of being addressed, also known as management actions. In 2020, the Lower Menominee River was the first Wisconsin area of concern to be removed from this list of degraded shoreline communities. And we're here during this virtual tour today to talk about the work needed to get Milwaukee off this list as well. So what is the Milwaukee Estuary? The Milwaukee Estuary is covered by the blue shaded areas in this map that indicate the 4 watersheds that overlap with the AOC boundary. These land areas drain into the rivers and eventually into Lake Michigan. The Milwaukee Estuary AOC more specifically focuses on the portions of these waterways that are included in yellow on this map. These are areas that are targeted for cleanup of historical contamination and environmental degradation. The AOC covers 2 counties: Milwaukee County to the north, Milwaukee County to the south, 3 primary tributaries: the Milwaukee, Menominee, the Kinnickinnick, 3 secondary tributaries: Lincoln Creek, Cedar Creek, and the Little Menominee River, and it also spans over 13 municipalities. So this area of concern is one of the larger area concerns throughout the Great Lakes. So how do you fix an area of concern? In order to no longer be listed as an area of concern, we must address the issues that aren't allowing the public to fully use or enjoy their water resources in a safe way for eating, drinking, swimming, fishing, and so forth. In general, we have organized the work into 3 objectives. The first one, cleaned up waterways, which also includes improving water quality. The second one, restoring fish and wildlife habitat and populations. And the third one, improving outdoor recreational opportunities like swimming, boating, and fishing. Of course, there are a lot of details and specific projects that contribute to each of these objectives. And during this virtual tour, we'll be focused on the cleaned up waterways objective and addressing the remedy needed to help address the overall work of the goals listed here. Next slide. Addressing the wide-ranging objectives of the AOC and accomplishing the work necessary to get Milwaukee off this list can, of course, not be done alone. It requires a significant level of collaboration and partnership. The Waterway Restoration Partnership, as you see here, is a group of long-standing trusted partners in the community who have been working together for years to improve water quality in this area. It's currently made up of project sponsors, those that are implementing the work, as well as other governmental and non-governmental organizations actively participating in work groups, and represents over 150 individuals and over 20 organizations. And with a once-in-a-generation opportunity, the organizations you see are formalizing our partnership and doubling down on our commitment to work together to clean up the Milwaukee Estuary AOC. If you'd like to continue following the work of the partnership and learn about ways that you can get involved, you can visit the website that's shown on the screen here, www.mkewaterwaypartners.org, or you can email the email address at wrp@mkewaterwaypartners.org to connect with us for more information. And the Community Advisory Committee is one of the groups that are ultimately working to ensure that Milwaukee residents, especially those underrepresented or excluded from environmental decision-making, play an active role in making decisions about shared waters and how AOC funding will be spent. The CAC serves as the voice of the community in the process of cleaning up Milwaukee Estuary AOC. They're one of the WRP partners, and they do this by creating and facilitating conversations between the community and the regulatory authorities in charge of completing this work. They do this by ensuring the community's concerns and ideas that are recognized and prioritized. They build on the community's voice into planning and decision-making about AOC projects, and they also support outbound communications and efforts to broaden the reach of AOC engagement efforts. So with all that being said, I'm going to send it over back to Port Milwaukee with Brian Kasterzak to talk about the existing sediment structures within the AOC.
Thank you, Brennan. So I am Brian Kasterzak with Port Milwaukee, Chief Engineer. And I'm just going to give a quick overview of the existing structures that are in Milwaukee Harbor. So first of all, you hear the term CDF. So at the Milwaukee Harbor Confined Disposal Facility, or CDF for short, which is located on the southeast end of Jones Island, was constructed by the United States Army Corps of Engineers in 1975. Prior to this, the dredged material from Milwaukee Harbor was typically open water placed, where they took it out to the deep parts of the lake and just dumped it. This CDF here in Milwaukee was 100% federally funded. It's approximately 50 acres in area and was designed to contain 1.6 million cubic yards of sediment. The north and east sides of the structure are rubble mound revetments, and the southern wall is a circular steel coffer dam to accommodate vessel berthing. The majority of the sediment disposed in the CDF is from dredging the federal navigation channels of Milwaukee Harbor. Material from federal projects in Port Washington also found a home in the CDF. The southern portion of the CDF was closed and capped first and is now home to the Lake Express car ferry, built in 2004, and the South Shore Cruise Dock just to the east of there. The remaining portion of the CDF was filled to capacity and closed following the 2008 Great Lakes Legacy Act project that removed approximately 180,000 cubic yards of contaminated sediment from a portion of the Kinnickinnic River. The KK River cleanup effort was a partnership between the EPA, DNR, the city, and Port Milwaukee. So similar partners, and there's, again, extended to community partners as well. So that was one of the first projects that is similar to what we're trying to do here at the AOC. Prior to the CDF's full closure and that final portion of the KK River sediment, there were studies and alternatives looked at for a new facility that have already been in the works. It was decided to build the new facility on top of the existing enclosed CDF. This facility is currently the active Dredged Material Disposal Facility, or DMDF. Sorry, next slide, please. But that is a good picture of it. This is just a closer up. And the DMDF was constructed in 2011 as a federal project with a local cost share. Port Milwaukee received a $1.5 million Harbor Assistance Program grant to help support this project. The DMDF is approximately 30 acres in size and was designed to contain just over 500,000 cubic yards of material. The Corps of Engineers has capacity for federal dredging projects, and the port has a portion of capacity for local navigational dredging and other permitted projects. As the first project in the overall Milwaukee AOC cleanup, We Energies will be using a portion of the port's capacity in the existing DMDF for removed contaminated sediment from the Milwaukee River in the 3rd Ward. There are currently 22 active federal disposal facilities on and around the Great Lakes. So this is a very important, feature that we have and we're lucky to have for Milwaukee Harbor. It keeps costs down for dredging projects. And so I think it's, sorry about that. And that's all I really have for this right now. I'll just pass it over to Bridget and she'll talk about the new structure that's being proposed. Thank you.
Thanks, Brian. Bear with me a moment here. I'm having a little technical difficulty putting my video on. There we go. So hi, I'm Bridget Hank. I am the project manager for the Dredged Material Disposal. Let's try that again. We love acronyms. They get really messy. So we're now going to move into the Dredged Material Management Facility, or the DMMF. I'm the project manager for the DMMF, the future facility, and I'm a senior project manager for the Milwaukee Metropolitan Sewage District. So what is a dredged material management facility? It's a near-shore engineered structure that provides for long-term safe containment of dredged material removed from our Milwaukee rivers and bay. In more simplistic terms, it's essentially a bathtub that is designed to hold sediment. The proposed facility is adjacent to South Lincoln Memorial Drive, directly north of the Lake Express Ferry, and next to the existing confined disposal facility. It's near Port Milwaukee's wind turbine and the south side of the Hone Bridge, as you can see in the photo on your screen. To give you an idea of how large this facility will be, the photo on the screen is at the southwest corner of the proposed facility. It starts at this rock area and will extend almost all the way to this liquid cargo pier, which is the skinny, narrow pier in the distance in the photo. The facility itself will be as wide as the existing liquid cargo pier and as wide as the existing CDF. It will be approximately 42 acres in area and will be large enough to hold 1.9 million cubic yards of material. That's equivalent to 12 football fields stacked 50 feet high with sediment. To give a better idea of the facility size, the location is shown on this map on the left side of your screen and bounded in this gold color. So we're proposing a facility that has 2 parallel rows of sheet piles, shown in the cross section over here, filled with a granular material and tied together with tie rods. In the middle of that granular material is something called a bulk barrier. That bulk barrier will prevent this facility from leaking. That bulk barrier is approximately 2 feet wide and made of a dense concrete-like material. To give you an idea of what the construction of a bulk barrier looks like, the top photo on your screen shows one way the bulk barrier could be installed. This method is called the secant pile construction. This construction method uses overlapping piles to create that watertight barrier. The bottom photo shows a similar dredged material management facility being built in Canada at Randall Reef. In the photo, they're filling the area between the sheets with granular material. You can see the sheets on both sides and the tie rods between them. For those that have attended previous DMMF presentations, you may have noticed that we've made a change to the style of the containment facility. While we were working on our state statute change that allows the Milwaukee Metropolitan Sewage District to build the structure, we took that opportunity to competitively bid the remaining design work for the project. The new designer, Ramble Engineering Americas, looked at the project with a fresh focus and provided some alternatives for a more robust facility. The dual wall with bulk barrier alternative was chosen for that final design. This significantly reduces the operation and maintenance costs for the facility while still providing a watertight nature. So what is the timeline? The design team is working on all of those details of the design and plan to have that design completed in spring of 2023. Once designed, the plans are bid and a contractor is selected. It will take approximately 2 years to build the DMMF. Once constructed, the first phase of filling the facility will begin. This phase is being led by the Environmental Protection Agency. The filling will be relatively quick, taking approximately 2 years. Then that material will need to settle. As it settles, Port Milwaukee and the Milwaukee Metropolitan Sewage District will be able to place more material from our projects into the facility. Overall, the facility will not be ready to be capped and made into usable land for at least 25 to 50 years. So in order to build the DMMF, we have to relocate a combined sewer overflow. Combined sewer overflow 195 is adjacent to the facility. I'm also the project manager for that project. So many of you may not know what a combined sewer overflow is. It's an emergency measure used in a heavy rain event when the inline storage system is full. The inline storage system is commonly known as the deep tunnel. When the system is full and the water reclamation facility, our Jones Island water reclamation facility in this case, can't keep up with the rain event, the gates are opened and the combined sewer overflow occurs. This is done to keep that water out of your basements, to prevent those basement backups. There are less than 2 overflows a year. So going back to this particular combined sewer overflow, it discharges into the footprint of the proposed dredged material management facility. This combined sewer overflow will need to be relocated so the DMMF can be built. The existing combined sewer overflow pipe is shown in the cross section on the right. It is nearly 20 feet wide and 10 feet tall. It's a twin structure, so there is a wall in between. And you can see, the access hatch where it discharges into the lake on the left-hand side of your screen. And this is right into that DMMF footprint. So what are we proposing? On the left-hand side, this is the proposed relocation alignment. It's going to go north along Lincoln Memorial Drive and discharge just north of the proposed DMMF and just south of the liquid cargo pier. The proposed structure is 18 feet wide and 10 feet tall. It's proposed to be a precast box culvert, which is similar to what you see on the left-hand side of your screen. The combined sewer overflow relocation construction is anticipated to begin in late 2022 and completed in 2024. There may be some overlap with the Dredged Material Management Facility construction, and that is totally acceptable. We can work in the same similar areas. Additional information on the combined sewer relocation will be presented in the fall as more details are developed and those construction plans are put together. I'll now turn things over to Brennan.
Thanks, Bridget. Like I mentioned earlier, I also have the pleasure during this virtual tour to talk about the future contaminated sediment cleanup that will use the proposed Dredged Material Management Facility as the final holding area for this contaminated material. And for simplicity and to not talk about a bunch of acronyms this whole time, let's refer to the facility as the Sediment Management Facility for the purposes of these next slides. So if you want to go to the next slide. And so first we can start about what we are trying to do, and our goal for this massive cleanup project is to remediate roughly 12 miles of the Milwaukee, Menominee, and Kinnickinnick rivers, as well as parts of the Milwaukee Bay that have contaminated sediment, which is what you see here on the map, areas highlighted by yellow. In total, the contaminated sediment is spread over roughly 500 acres and has a volume of around 300 million cubic yards. And of course, not all of that material can be removed from the system, as there are many physical objects in the way, such as steel sheet pile walls, utilities, and bridge abutments that cannot support dredging immediately next to them. Between 1 to 2 of the 3 million cubic yards material is removable. This means that capping or creating a barrier between the sediment and the water will also be an important remedial technology for the overall cleanup. However, for today, I want to focus on the dredging portion of the cleanup, as that is the more challenging component of the work and the focus of this virtual tour. So you want to head to the next slide. So first, we'll just cover a brief introduction to dredging. On the slide, you can see a basic type of dredging. It's referred to as mechanical dredging. It uses a crane and a cable-driven clamshell bucket. This process picks up the sediment from the bottom of the river or the harbor and transfers it to a barge, one scoop at a time, or also one bite at a time, to then be transported to another location for further processing. The second basic type of dredging on the next slide is with a hydraulic dredge. The cutter head shown here is placed down in the sediment and loosens the particles, which are then entrained in water and pushed with a pump through a pipeline to another location. A good analogy is that a hydraulic dredge can be thought of as an underwater vacuum cleaner. It takes up all the sediment and water and moves it to its next location. Both types of dredging, either mechanical or hydraulic, will likely be needed for the cleanup. Each tool is better at different jobs. Hydraulic dredging has less sediment left over, also known as dredge residuals, and has an advantage that the barge's ladder arm can reach under objects like river walks, but are not as good as handling debris and large objects like mechanical dredging. They generate more water than requires more treatment for hydraulic dredging. Conversely, for mechanical dredging, it generates less water and can handle the debris, but requires more support equipment. It is not quite as clean as the hydraulic vacuum cleaner. Most of the dredging is likely to be hydraulic for this project, but the new sediment management facility is designed to accept both types of dredging. Next slide. Next, we're going to discuss some of the challenges that are common to contaminated sediment cleanup projects, particularly focusing on dredging. To be able to do the dredging, we must talk about what happens to the sediment after it's dredged, which is the more complicated part of the process and often the limiting factor. Disposal, or putting the mud down after it has been picked up, is typically the costliest part of a contaminated sediment cleanup project. There are many reasons for this, but ultimately landfills are not designed to take sediment without first turning the sediment into soil. The sediment, which contains a lot of water, must be dried or perhaps even cured. The curing process has a lot of steps and requires quite a bit of infrastructure and space, for which is shown on the screen here. The infrastructure includes a lined asphalt sediment processing pad with containment walls, which you can think of as a parking lot that doesn't leak. To cure the sediment, heavy construction equipment mixes in amendments such as lime or various types of cement to create a chemical reaction with the water. This curing process takes a few days and at the end allows it to be accepted at a landfill. Now let's talk about the solution on the next slide for the new home for the Milwaukee Estuary AOC. The new sediment management facility addresses common challenges with a sediment cleanup and is different than a typical landfill. First, the fundamental benefit is that the sediment does not have to be cured before it is put in the facility, and once in the facility, it is at its final destination. This is extremely beneficial because the best process is, in fact, no process. We don't have to build an enormous sediment managing processing pad, and for reference, the past processing pad on the previous slide that was shown is to clean up 30,000 cubic yards of material in the Portage Canal. We're addressing 1 to 2 million cubic yards. We also don't have to use heavy construction equipment to dose the material with amendments, cure it, load it into a truck, drive it to the landfill, have the landfill operator spread it out, and be limited to a 3 o'clock cutoff time at the landfill for which the operator is done working for the day. All of that process and money it takes to handle the material multiple times is eliminated by using the sediment management facility. Additionally, the facility itself is part of the water treatment process. You can think of the new facility as a giant clarifier, performing the function of primary treatment. Analogy that was previously referenced by Bridget is similar to a large bathtub. Imagine that someone is pumping mud into one end and there is a sand filter at the other end. By the time the water gets to the other end of the tub, the particles will have started to settle out through the water column and starting to collect on the bottom of the bathtub. In short, this is helpful for when the water treatment plant reduces the costs for extra holding tanks that otherwise serve this purpose. And finally, let's bring it all back together. The centrally located sediment management facility facilitates the large scale cleanup that we're proposing to do by eliminating multiple steps throughout the remedial process. It helps to treat the water, eliminates trucking and disposal, and this allows multiple dredges to operate in the AOC simultaneously, connecting directly to the facility. The facility meets our needs as an AOC and enables us to progress towards addressing the largest issue in most area of concerns, which is contaminated sediment. If you want to head to the next slide, please be sure to stay involved within the AOC and as part of this cleanup. As I previously mentioned before, you can visit the Waterway Restoration Partnership website at wrp@milwaukeewaterwaypartners.org. You can also attend future events and stay in touch through signing up for the newsletter on that page and also emailing the WRP email. Thank you for your time and hope to see you at a future event.